So 5.7 is the natural log functions integration. I think 5.7 is really easy. There's one homework question that's kind of a little bit different, but everything else is pretty quick. I did 5.7 and 5.8 last night and this morning. When I say last night and this morning, I spent about 20 minutes on 5.7 tops because I was doing a bunch of other stuff while I was doing it. And then this morning I finished 5.8 before school started. So, I mean, it's really quick. 5.7, this 7 minutes is really quick. And it's, again, it's not very hard. So let u be a differential function of x. Here are your rules. The integration of 1 over x dx. We already know as ln absolute value of x plus c. And then 1 over u du would be ln absolute value of u plus c. You're not doing anything different today than you did with 5.5 and 5.6. Okay, well, 5.5, 5.6 was Simpsons and Chuck Ford, so it was kind of rough. All right, using a log rule for integration to find the integration of 1 over 2x dx. It tells you to let u equals 2x, and then we take the derivative du is equal to dx, or 2 dx. So when we look at this, we want the integration of 1 over u du. But the problem is I have 2 dx, and I don't want that. So what do I need to do? And I'm going to put that on the outside. So 1/2. So then we're going to have 1/2. What's the integration of 1 over u? Plus c. What was u? So 1/2 ln absolute value of 2x plus c. I think it'll confuse you a little bit because it gave you what u was, but you already know what u is. Okay. Look at your next one, log rule with the change of variables. We would pick u to be 4x minus 1 so that we could do 1 over u du. But again, when I do my integration, just so you guys can see it, if I pick u to be 4x minus 1, and again, I know it's up there, but I want you to see it like we've been seeing it. It gives me 4 dx. I don't want 4 dx, I want 1 dx. So what do I have to do? So this is the same thing that we've been doing. So we're going to throw our 1/4 to the outside. So we're going to do 1/4. What's the integration of 1 over u? ln absolute value of u plus c. And what was u? And that's it. So nothing any different than we've been doing. The next one says integrate the area of the region bounded by the graph of y equals x over x squared plus 1. The x-axis and the line x equals 3. So the x-axis is going to be 0. So our integration is going to be from 0 to 3. So we're doing the integration 0 to 3 x over x squared plus 1 dx. You good? Okay. What do we do? Same thing we've been doing. What do we do? Find u. What is u? So then? But I just want x dx. So what do I have to do? So we're doing 1/2 of the integrations from 0 to 3 of 1 over u du. What is the integration of 1 over u? Again, from 0 to 3. What is u? So the integration is going to be 1/2 ln absolute value of x squared plus 1 from 0 to 3. And then what do I do? Plug in. So 1/2 ln, 3 squared is 9 plus 1 is 10. Minus 1/2 ln, 0 squared is 0 plus 1 is 1. And I can do positive 10 and positive 1 now because we can take the absolute value of regular numbers. So the absolute value went away when we did that. All right, when we put it into our calculator, this ln 10 1/2 is 1.151. ln 1 is 0 times 1/2 is 0. So your area is 1.151. Done anything hard yet? Same thing we've been doing, right? It's honest to God, no different. All right. Any questions first page? Everybody good? All right. Recognize quotient forms of the log rule. Quotient forms of the log rule. Integrate each of the following. Same thing we've been doing. So what do we do? Which one is you? Why do we pick x to the third plus x? When you find the derivative, it's going to be 3x squared plus 1, which is the top. So that changes this into 1 over u du. We don't even have to fix anything. Which means that our antiderivative or our integral is ln absolute value of u plus c. And what was u? And that's it, y'all. Same exact thing. I'm going to jump down to C. We'll come to the trig functions in a minute. Jump down to C. Which one is going to be your u? The bottom. Because when I take the derivative, I get 2x plus 2 dx, but I just want x plus 1. So how can I make that look like x plus 1? Divide by 2. So this is going to be 1/2 of the integration of 1 over u du. So 1/2 ln absolute value of u plus c, or 1/2 ln absolute value. Our u was x squared plus 2x plus c. Sorry, I switched that up. I'm only skipping B because it's a trig function, not because it's hard. I hope y'all understand that. Like I'm not just, okay. D, what am I going to use? And then du is going to be 3 dx. So what do I have to do? So we're going to do 1/3 integration of 1 over u du. So we get 1/3 ln absolute value of u plus c. And then our u was 3x plus 2. Everybody good with those 3? All right, so what am I going to use on B? Every one, we've used the bottom, right? We're going to use it again so that we can do 1 over u. What's the derivative of tan x? Okay, so we get du equals secant squared x dx. This is just normal, 1 over u du, nothing else. 1 over u is ln absolute value of u plus c. Our u was tan x, so ln absolute value of tan x plus c. I would not use the top it off. Is everybody good? All right, integrals to which, excuse me, the log rule can be applied often if you're in disguised form. For instance, when a rational function has a numerator of degree greater than or equal to that of the denominator, division may reveal a form to which you can apply the log rule. You guys see this? Y'all remember long division? Well, you better start remembering real fast. It's not that bad. So these are, they're not really hard long divisions like in math 3 you had some that were like really long and crazy. These are trinomials, binomials at best. So they're not very long. So what you're going to do is do your long division before. So it's always the bottom on the outside of the division. And then we have x squared plus x plus 1 on the inside. There are a couple of these on your homework, 1 or 2. It's not like every one of them. Okay. Everybody good? What you want to do is what can I multiply by x squared to get x squared? 1. You're going to distribute that x squared to the top right here. Then you get x squared. There is no x term, but there is a 1. So make sure that you have that. Typically, you want to put that 0x in there anytime it skips, but I figured y'all are smart enough to understand, like we don't line up not like terms. Does everybody understand that? To get them to cancel out, we change all the signs. 0 can change, but there's no positive or negative. So it cancels this out. And it leaves me with just x because these two cancel out as well. This x is your remainder, and the way that we write this is your answer, which was 1, plus x over x squared plus 1. Any questions about that? It's always over whatever you divided by. Everybody okay? We're going to do this a couple times. I think. No, might have to do it in our homework. Yep, that's the only example we have. All right. So then you're going to change your integration to 1 plus x over x squared plus 1 dx. Remember when we have addition, we split it up. So what's the integration of 1? So I'm gonna put that over here. Then we're going to do the integration of x over x squared plus 1 dx. How do we do this? We've already done this like 1,400 times today. U is x squared plus 1. Du is 2x dx, but we only need what? X, so we're going to divide by 2. So we're going to do 1/2 of the integration of 1 over u du. So we get x plus 1/2. The integration of ln, I'm sorry, the integration of 1 over u is ln absolute value of u plus c. And then you plug in your u. This one?
Yes.
No, it's the integration of 1. We split it up. Sorry, if you want to write that. That's what we did. All right, integrate the indefinite integral 2x over x plus 1 squared dx. And this one is change of variables. That means at some point you're going to have to plug in for x. Okay, so you guys remember those where we had to solve for x and then plug in. So when we write this, what is our u going to be? Everybody good with that? What is your du going to be? 1 dx. But what do we have up here? We have that 2x. What can I do with that 2 to begin with? I could go ahead and pull it out. You can also leave it there. It doesn't matter. It's not going to hurt anything. It's up to you, whatever you want to do. So if we pull it out, we have the integration of x over x plus 1 squared dx, but I'm still going to have that x. So this is how I know I need to do a change of variables. So I want to solve this u for x. How do I do that? Minus 1, right? All right. So this changes into 2 times the integration of u minus 1 over u squared du. How do I work this? Say it again. Split it up. U over u squared du plus, not plus, but minus the integration of 1 over u squared du. Clean it up again. What is u over u squared? 1 over u. What do I rewrite this as? 1 over u squared. Yeah, remember that we just don't change the single u on the bottom, we change everything else. And now we can integrate. All right, so I'm gonna come back over here and I have 2 times, what's the integration of 1 over u du? ln absolute value of u. You don't have to put your plus c yet, wait till the very end. Minus, what's the integration of u to the negative 2? And then we're gonna have a plus c. Clean it up. 2 times ln absolute value of u. What does this change to? And then it's a minus negative, so positive 1 over u. Almost done. Plug in your u, distribute your 2. So 2 ln, what was u? X plus 1 plus 2 over u was x plus 1. And then make it general with a plus c. So not terrible, not terrible. How do you know you have to change the formula or change the variables when you have an x left over? Is everybody good? Okay. Use substitution in the log rule, solve the differential equation. Anytime it says solve the differential equation, we're going to do integration. So we're going to integrate 1 over x ln x dx. What's going to be your u? Yes. ln x. What's that derivative of ln x? 1 over x, right? Do we not have that on our paper right now? So if we take away that ln x, you guys see how it's 1 over x. So if you need to see it a little bit better, you can split it up like this. And then we're going to set our u equal to ln x because our du will be 1 over x dx. So that takes care of this part, which leaves you with 1 over ln x, or we changed ln x to u. What's the integration of 1 over u? ln. And what was our u? That's it. So same exact thing, just watch these. I think you see that a lot in your homework. That's it on that part. All right. Integrals of trig functions in section 5.1, you looked at 6 trig integration rules, the 6 that corresponded directly to differentiation rules. With the log rule, you can now complete the set of basic trig integration formulas. You will need these for your homework. There's a whole list of them, in the front of your book. So you can flip back and forth to do that. So find the integration of tan x. So the integration of tan x, we're going to change into sine over cosine. This is basically showing you how they derive the formula, okay? Our u is going to be the number on the bottom, or the function on the bottom, which is cosine x. What is du? Emma, what's the derivative of cosine x? It is negative sine x. But I just want positive sine x. So what do I do? So then I have the negative integration of 1 over u du. Didn't we got this? Very good. What does that give me? I'm sorry, ln u plus c. And what was u? If you'll look, you don't have to right now. If you look in the front of your book, the integration of tan is going to show you that right there. Okay. So if you can just memorize the rule, you don't have to do the work. All right. The secant formula. This one, please understand. You're just deriving this. This is the hardest example that you're going to have in the next 2 sections in your homework. Okay. It's hard to look at. Just hear me out and I'll explain where everything comes from. But I don't know that I would expect you to be able to do this. It's really crazy. You got to know a lot of the rules. All right. So if we derive secant x dx, we can change it into, good gracious, secant x times secant x plus tan x over secant x plus tan x. Come on, hold off for that just a second. What is secant x plus tan x? It's not a hard question. Think about it. Over secant x plus tan x. It's 1. So am I really doing anything? No, I'm multiplying by 1. So I'm not changing the value. I'm just changing the way it looks. Why do they do that? They do that so then your integration, when we distribute this in, will be secant squared x plus secant x tan x over secant x plus tan x dx. Now they can do the 1 over u. Okay, so remember our bottom is always going to be our u, right? Okay, think way back. What is our derivative of secant? What's our derivative of tan x? Notice the top of that equation that we just had a second ago. You guys see that that is your du. So now we've changed it into 1 over u du. What's the differentiation, or not differentiation? What's the integration of 1 over u? Ln absolute value of u plus c. And then what was our u? Secant x plus tan x plus c. This is the actual integration rule that you will see. Okay, so if you memorize it, you don't have to worry about it. Everybody got it? All right, so here are those integration rules, and then we have 2 examples, and then we're done. And the 2 examples are definite integrals, so we're just plugging in. Same thing, and we can use these up here. So the integration of sine is negative cosine u plus c. I'm gonna just go straight down, and then I'll move over to the other one. Tan u, we figured out, was negative ln absolute value of cosine u plus c. We just did that one. And then we just did secant u, which was ln absolute value of secant u plus tan u plus c. Cosine u is going to be sine u plus c. Those are ones we've already learned. Cotan u is going to be ln absolute value of sine u plus c. See how these are opposite? Remember, cotan is 1 over tan, or it would be cosine over sine instead. So that's why they're flipped like that. And then cosecant is negative ln cosecant u plus cotan u plus c. And again, those are listed in the front of your book, so you don't necessarily have to reference your notes, but you'll be using them. All right, so evaluate the integration from 0 to pi over 4 of the square root of 1 plus tan squared x. What's your u going to be? So then what should du? What's the derivative of 1? What's the derivative of tan squared x? Is it secant to the 4th? It's just going to be secant squared x. Okay. So we're doing the integration. I'm sorry, I lied to you. I lied to you. Not this part. What is 1 plus tan squared x? It is secant squared x. That's your trig identity rules. I'm sorry, yeah, that's me. The reason we're going to do that is because what's going to happen right here? It's going to cancel it out, right? It should be pi over 4. So 0 to pi over 4 of just secant x dx. We don't even have to use a u. What is your integration of secant? It's right here. And remember, we're doing that from 0 to pi over 4. So we're going to do ln absolute value of secant pi over 4 plus tan pi over 4 minus ln secant 0 plus tan 0. Secant 0 plus tan 0 is going to give you all of that backside is going to give you 0. How do you put secant in your calculator? Okay, so when you type it in, you're going to have ln alpha y equals 1 over cosine pi over 4 plus tan pi over 4. Is everybody good with that? That gives us 0.8814. And I told you when you type in the other stuff, it's going to give you 0. So your area or your definite integral is going to be 0.8814. What's the difference in the next one? What's it ask you to find? What do we have to do for average value? You guys remember from the last time? What's the average value? It's the x u du. So it's 1 over b minus a in front of your integral. So 1 over, what's your b? Pi over 4 minus 0 of the integration. What's our function? Dx. Again, from 0 to pi over 4. So we have 1 over pi over 4. I don't divide fractions. What do I do? Flip and multiply. So it'll be 4 over pi, 0 to pi over 4 of tan x dx. We have a rule for tan x up there. What's our rule for tan? Absolute value of cosine u. From 0 to pi over 4. So you're going to do 4 over pi negative ln absolute value of cosine pi over 4 minus, or change to plus, ln cosine of 0. Cosine pi over 4, close your parentheses, absolute value, close your parentheses. We get 4 over pi, 0.3466. We have a positive cosine 0, gives you 0. So then you're going to take that number, multiply by 4 over pi. And we get 4.4413. Any questions? Everybody good? All right. Here's your homework. Page 354. 5, 9, 11, 15, 23, 33, 37, 43, 51, 53, 73. And again, you'll see the first couple take no time at all. I think there's one. Can't remember if it's this one or the next one that you have to do the X on. But that's it. And I took off the hardest one, so. Is everybody good? Got this? All right. I was just kidding.